A very good morning to all my dear students. Welcome to your science class. So, today we are going to proceed in the chapter Motion and Time. In the previous module, we have already studied about this what is the speed and how we can calculate the speed. So, students, if we know the distance and the time, so we can easily calculate the speed of the moving object or a body. Now students, what is the apparatus used for measuring the speed of a moving object or vehicle? It is speedometer. So students, have you ever observed the dashboard in your car? So students, there you can see this kind of a structure, and this is known as a speedometer, and the speed of the vehicle, the speed of the moving object vehicle could be measured by this apparatus. An odometer is used to measure the distance moved by the vehicle. Students, now we are going to talk about the distance time graph. So before we proceed further to understand about the distance time graph, we will first understand what actually graph is all about. So students, here as you can see that graph is any available data can be represented in the form of graph, which can be bar graph, pie chart, or a line graph. Students, you must have studied in mathematics, or if you have ever been just observed a magazine or a research paper, if you have ever seen it, so there you must have seen a circular graph showing, like in your geography book, you must have seen that the 1/3 portion of the earth's surface is covered by water. So students, 1/3 portion is covered by the land, and the rest of the portion is covered by water. So in this way, that strata is shown in the form of pie graph. And you must have seen that the population has been always represented in bar graphs. Okay, so students, there are different kinds of graphs, and to plot the graph between the distance and time, the line graph is the most suitable one. So now we are going to proceed further. So students, here as you can see, first of all we use a graph paper to draw the distance time graph. Then students, the side of the bigger square, see students, this is a bigger square. If you just I have just zoomed out the graph paper, so if you will just see the sides of the bigger square, so this one side is considered to be, as this is a square, so all the sides of the square will be equal, so it is considered as, it is actually 1 centimeter, and the smaller square is 1 millimeter. Now students, the graph paper has 1 centimeter squares marked on it. Each centimeter square has 100 small squares in which are millimeter squares. Now, as you see students, how to draw the distance time graph. To draw the distance time graph, first we have seen that we should have a graph paper, and the other things is that we should have a reading. We should have a experimental reading observed. So to draw the distance time graph for the moving object, we need a graph paper and the readings of the distance traveled by the object and the corresponding time values which have been obtained experimentally. Now students, this is example. As you see, this is the time interval that it is given in 0 seconds. Second is the unit of time. It is the SI unit. So it's 0 second, 2 second, 4 second, 6 second. And distance, as you can see that in 0 second, the distance covered is 0 meters, and in 2 seconds, the distance covered is 10 meters, and likewise. So students, as you can see here that the different intervals are given, and the different data is given over here. So now we are going to plot, we will see in the further slides that how we can plot these data in the graph. So student, first of all, if we want to plot a data in a graph, we should draw a horizontal line and on the graph paper to represents the x-axis. So this is the horizontal line which is x-axis, and label it as x-axis. And suppose on the x-axis we are marking the time, so the unit of the time should be there in the bracket. So it can be in seconds, it can be in minutes, and or in hours. So an arrow will be marked over here. So the next step will be horizontally, we have already discussed in the previous slide, and then we will just draw a vertical line on the left side of the graph paper to represent y-axis. Label it as y-axis, and by writing the word distance on it, it can be distance or anything. If you are finding relation in any two readings, you can just mark it once on one thing, you can mark it on the x-axis and the other thing on the y-axis. So similarly, we have marked time on the x-axis and distance on the y-axis, and the similarly SI unit or any the data which is given in that unit, we have to write it in the box. Now students, where these two axes are meeting, we will mark it as O, and that is known as origin point. So here, as you can see students, that the SI unit is given in the bracket and the arrow is marked after that. So we should choose suitable scales as to represent the large values of time and distance conveniently on the small graph paper. See students, if a data is very large, so and a graph paper is very small, so we will just divide the data, we will just take the range, okay, and we will will take it as scales. Like we have seen that the readings was there in 2, 4, 6 seconds. So similarly, so students, the scale could be used depend on the range of the time and distance values, hence vary from question to question. Now students, see that this is one of the data given over here, and we will just mark the time, and as it is given over here, we will just mark it that 1 centimeter is equals to 2 seconds. So we will write it here also as a we will see just in the next slide that how we can just write the scale. So at the right side of the graph, and here as you see the distance is also given. Now here as we will see that in 2 seconds the distance covered is 10. So likewise we will just mark the cross and then we will join it. So like 4 seconds, at 4 seconds the distance covered is 20 meters. Similarly, I have marked the cross and then join all the marks with a pencil, and then you will see that you will observe a straight line. So we deal with the distance and time graph while studying the motion of bodies. If we record a distance time graph for a body and plot the same data on the rectangular graph, we will obtain the distance time graph corresponding to the motion of that body, and by using the graph we can find the speed of that body. So in this way we can find the speed of the moving body. Now students, as you can see here that there is a uniformity. We have discussed it in the previous module that what is speed and what is uniform and non-uniform motion. So the uniform motion is when there is a uniformity in the time and the distance covered. So here as you can see that there is a uniformity in it, so it will be a uniform motion graph. So it will, if it is a uniform motion, so the graph will always be a straight line. And but if it is not possible students that the motion of any vehicle be in a uniform motion, it is very rare. If there is traffic, so we will have to just brake put brakes, no, and we have to just slower our speed of the vehicle. So students, in that case, you would be able to see that in 2 seconds the distance covered is 10 meters, and in 4 seconds the distance covered is 30 meters. So here you can see that the distance traveled in the same interval of time is not similar. So when there is traffic, so the distance will be slow, the speed will be slower, and hence the distance covered will be lesser. And when there is no traffic, so the distance covered will be more. So in this kind of data givens, the graph which you will plot will not be a straight line, and it will be in a random way. So it is known as uniform motion. So when we will just draw a line through these cross marks, so you will observe that it will look like in somewhat random way. It is not a straight line. So students, if I'll say that if you want to see a graph of, if it is something like this, that at this interval of time the distance covered is this, so it will be in parallel. So the time will be, the distance covered will be parallel. So students, it is one of the example given in your book, that this is the reading that at time 8 the journey has started, and in odometer the reading is 1221 kilometers covered. It must be a previous journey the vehicle has covered. So in 5 minutes the distance covered is 2 kilometers. In 10 minutes it has covered 4 kilometers. So you can see a uniformity in it. So when you will plot a graph between the time and the distance, so you will see that you will observe a straight line. So the motion is uniform. So similarly students, when you will see that the distance covered by the moving object, and this is one data is given over here, so how you will represent it on the straight line. So hope students, you have understood that how you can plot the graph. Okay, I have already told you that I have shown you the graph paper and how it is being divided, and the one square is considered as 1 centimeters, and we can mark the scales. So here you can see that it is a straight line, and stepwise it is given over here, that while putting the data in the graph, that it is very important to mention the scale. See, as it is given over here, that x-axis, the 1 centimeter, the time is 1 centimeter is 1 seconds, right? So as you can see here, at the y-axis, 1 centimeter is equal to 2 meters. So similarly, it is very important to mark the scales, and then you can see that in this way we can plot. So whatever I have already explained you is written over here, and you can just pause the video and read the following points. So the distance time graph representing the movement of the body is ready, and the distance time graph of a body moving is uniform. As you can see, it is a straight line. So similarly students, one example is given in your book, example 6, that you will do it on your own, and it is very easy, that you will have to graphically represent the movement of the body and find its speed. And what information you already know, that this formula of the speed is distance traveled upon time taken, which I had already told you in the previous module. So in this way, when at 3 seconds, what you will do, you will just mark on the 3, you will draw a horizontal line, and then you will straight from there you will just plot and where the point will intersect. As you know, the draw perpendicular at the x-axis, and then it will drop down at the 3 seconds, and which intersects the graph at T point. And now draw the line from the T point parallel to the x-axis, which intersects at y-axis, and this point will be considered as B, and you can conclude that the speed of the moving body. So here you can see that what you observe from this graph, you can see the distance traveled by the body at a particular interval of time, the speed of the moving body, and the speed. So you can, in this way you can calculate the speed of the body. So students, hope you have understood the distance time graph. Thank you students, thank you for listening. Hope you have enjoyed the lecture.